Welcome to Savi YouTube channel created by Sai Vidya Institute of Technology, Bangalore. In this session, let us continue some more problems on Thevenin's and Norton's theorem. So, the next problem is we have to obtain the Thevenin's equivalent circuit for this network across the terminals A and B. So, in this problem, A and B are considered as load terminals. Here load is not given, hence we are not finding any current or voltage in this problem. Just we are going to obtain Thevenin's equivalent circuit. What is Thevenin's equivalent circuit? So, a voltage source in series with a resistance. If this is the terminals A and B, so you have to find R Thevenin and you have to find V Thevenin. So, that means you have to convert this network into a single voltage source V Thevenin in series with a resistance R Thevenin. Now, let us find these two parameters so that we can obtain Thevenin's equivalent circuit. Now, step 1 to find V Thevenin. What is V Thevenin? V Thevenin is nothing but open circuit voltage across the load terminals. So, now we have to find open circuit voltage between the terminals A and B, that is your V Thevenin. How to find this voltage? To find voltages or currents in the given network, we have two laws. One is KVL, the other is KCL. KVL means we have to go for mesh analysis. KCL means we have to go for nodal analysis. Any one technique you can apply to find currents or voltages. Now, I will go for mesh analysis. Now, in this network, you have two meshes. So, what you have to observe here is, whenever there is a dependent source, so dependent variable must be given in the problem. Yes, it is given, purposefully I have not shown, but now I am going to write the dependent variable. See, this is a dependent source, symbol represents dependent source, polarity represents voltage source. It is depending on the voltage Vx, hence it is voltage dependent voltage source. This dependent variable must be given in the problem. Where it is given? Actually it is given across 15 ohm resistor with the polarity shown. If this is not given, you cannot solve the problem. This must be given in the problem to solve the problem. Now, you have two loops. I will solve by mesh analysis. Let us take this mesh current as I1. Let us take this mesh current as I2. Now, if I solve for I1 and I2, I can find the V Thevenin. Now, if you take this loop, in this loop you have a current source. Whenever you have a current source in the given network or in a given loop, you cannot apply KVL to this loop because you have current source. So, then you have to write current equation. What is the current equation? In this wire, 5 ampere current is flowing downward, it is given. In the same wire, the loop current is flowing. What is that loop current? I1 is flowing upward. Hence, current in this wire is known to you, that is 5 ampere. In the same wire, I know loop current I1 is flowing opposite to this, hence I can write I1 is equal to minus 5 ampere. So, what is current equation? Current equation is I1 is equal to minus 5 ampere. That is all. You cannot write any equation further. Then successfully I can apply KVL to second loop. What is the KVL to second loop? So, I will write sum of all the voltage drops on the left hand side, and then I am going to equate this to algebraic sum of voltage sources. What is the KVL now? 15 So KVL to loop 2 is given by 15 I2 minus I1, 15 I2 minus I1 plus 10 I2 is equal to what? Is equal to, you are moving clockwise. So plus 2 minus is minus 150, plus 2 minus is minus Vx by 3. Okay. So in this equation, final equation must be only in terms of the loop currents, but you have Vx now. Whenever dependent variable comes in the equation, you have to replace that variable in terms of loop currents if you are solving by loop analysis, and that must be replaced by node voltages if you are solving by nodal analysis. Now let us express Vx in terms of loop currents. So but Vx is equal to, what is Vx? Where is Vx? Vx is here. Vx is nothing but voltage drop across 15 ohm resistor. So you know, according to Ohm's law, V is equal to I into R. R is 15. What is the current here? Two currents are flowing. One is opposite to other. So I1 is flowing downward, I2 is flowing upward. One is opposite to other. Hence current flowing to this path is either I have to take I1 minus I2 or I2 minus I1. Which is correct? Whether I should take a Vx equal to 15 into I1 minus I2 or I2 minus I1. To avoid this confusion, whenever the dependent variable is voltage, they must specify polarity of voltage. Whenever the dependent variable is current, then they must specify direction of current in the network. Since here the dependent variable is voltage, they have given the polarity of voltage drop here. Now I want Vx with polarity up positive, lower negative. To get this positive, this negative, current should flow downward. If current flows downward, then I will get a voltage drop of polarity, this positive, this negative. Because drop means current should flow from higher potential to lower potential. That is called a drop. Therefore, which current is flowing downward? I1 is flowing downward. Hence, the polarity of Vx is matching with I1. Hence, I should take I1 positive, the opposite current I2 negative. Hence, what the difference of current I must take? That is given by I1 minus I2 only I should take. So, what is Vx now? 15 into I1 minus I2. 15 into I1 minus I2. You should not take I2 minus I1. That is very important when you are working out with the dependent sources. Now, let us simplify. 15 I2 minus 15 I1 plus 10 I2 is equal to minus 150 minus 15 into I1 minus I2 divided by 3. Then what will you get here? Minus 15 I1 plus 25 I2 is equal to minus 150 minus 5 I1 minus into minus plus 5 I2. Now I have to simplify this equation. Let us simplify this equation. What happens here? It becomes minus 10 I1. If you take left hand side, if you take this left hand side, it becomes plus 20 I2 is equal to minus 150. Now since I know the value of I1, if I substitute the value of I1, then I will get I2. Now substituting the I1 value in this equation, what we will get? We get I1 is equal to minus 5, minus into minus plus 10 into 5, 50 plus 20 I2 is equal to minus 150. Therefore 20 I2 is equal to what? Minus 150 minus 50 minus 150 minus 50, that is equal to, so I2 is equal to minus 200 by 20 gives minus 10 ampere. Okay, all of you observe here. So minus 200 is divided by 20 gives minus 10 ampere. Now you got I1 is equal to minus 5 ampere, I2 is equal to minus 10 ampere. Now what is my intention? My intention is to find V Thevenin. What is V Thevenin? V Thevenin is equal to voltage between A and B. Voltage between A and B is called V Thevenin. Since this is open, no current is flowing here, hence voltage drop here is voltage drop equal to 0. Voltage drop 0 means what? Voltage is 0 means what? It is a short circuit. Therefore, this point is same as this point. This point is same as this point. Therefore, V Thevenin is nothing but voltage between these 2 points, which is same as voltage between these 2 points. What is the voltage between these 2 points? It is Vx. Therefore, I can write V Thevenin is equal to Vx. So, V Thevenin is equal to Vx. So, what is Vx? Vx equal to 15 I1 minus I2. So, therefore, V Thevenin is equal to 15 I1 minus I2. Okay. If you substitute I1, if you substitute I2, we get V Thevenin is equal to how much? 75 volts. V Thevenin is equal to 75 volts. This is how to find the open circuit voltage for this problem. Next, what I should find? I should find R Thevenin. Now, let us go for step 2. Step 2 to find R Thevenin. To find R Thevenin. So, when you are finding R Thevenin, you have to see that in the given network, any dependent sources are there or not. If there are dependent sources, then to find R Thevenin, we are going to use this formula V Thevenin divided by IN. Whenever there is a dependent source, to find R Thevenin, you have to use this formula V Thevenin by IN. What is V Thevenin? Open circuit voltage across the load terminals. What is IN? It is short circuit current flowing through the load terminals. So, to find the short circuit current, what I should do? I have to create the short circuit across the load terminals, and then I have to find the short circuit current for the given network. That current is called short circuit current. Okay. Since I know already V Thevenin, now my intention is to find IN. Now, let us see how to find IN. So, to find IN is nothing but what? It is short circuit current. Short circuit current flowing through the load terminals. It is the short circuit current flowing to the load terminals. Therefore, what I should do? I have to create the short circuit. Let us create the short circuit. Okay, I have created the short circuit. Now I have to find this current that is called IN. Okay. Now the network remains same. We are not disturbing any network here. Just we are looking across the load terminals. Now again, if I want to solve this problem by mesh analysis, I have 3 meshes. Therefore, let us solve by mesh analysis. So, take this mesh current as I1, then this becomes I2, and this becomes I3. Now, you have 3 mesh currents. Again, if I solve for I1, then I will get the value of IN. Now, can you apply KVL to loop 1? Can you apply KVL to loop 1? No, because you have a current source. Can you apply KVL to second loop? No, because you have current source. Can you apply KVL to loop 3? Yes, because you don't have any current source. Now, in this problem, in this network, you cannot apply KVL to loop 1 and 2. You can apply KVL only to loop 3. You have 3 unknowns. To solve 3 unknowns, I need 3 equations. One equation I will get from loop 3. Then how to get two more equations? Whenever you have a current source, you have to write current equation. The number of current equations is equal to number of ideal current sources that are present in the network. Actually, this is not ideal current source. This is practical current source. Together these two is a practical current source. But in this problem, you should not convert this ideal current source, this practical current source into voltage source. Why? Because across this resistor, dependent variable is given, that is Vx is given. At any point of time in the given network, you should not disturb the dependent variable. It must be there wherever it is in the given problem. You should not disturb the dependent variable. Okay? Hence, I should not disturb it. Therefore, I will not disturb the whole current source. I will keep it as it is. I will take 3 loops. Now, what I should do? Since you have a current source, first let us write current equation. What is a current equation or constant equation? Means compulsorily you have to write this equation, the current equation for this. So, in this part of the wire, 5 ampere current is flowing downward. The same wire, 2 loop currents are flowing. Okay, one is opposite to other. Hence, current flowing to this wire is difference of these 2 currents. What difference I should take? I must take I1 minus I2. So, why I1 minus I2? Because the direction of loop current I1 is matching with source current direction. Hence, that current will be taken as positive, the opposite current will be taken as negative. Therefore, I can write a current equation for this current source, which is given by I1 minus I2 is equal to 5 ampere. So, I1 minus I2 is equal to 5 ampere. Let this equation 1. I need 3 equations. It may be current equation, it may be voltage equation. Next, successfully I can apply KVL to loop 3. KVL to loop 3. Let us apply KVL to loop 3. Applying KVL to loop 3, 15 I3 minus I2. 15 I3 minus I2 plus 10 I3 is equal to what? Moving clockwise, plus 2 minus minus 150 plus 2 minus minus Vx by 3. But what is Vx? Again same thing. What is Vx? 15 into I2 minus I3. Okay? Vx equal to 15 into I2 minus I3. Then simplifying here, what it gives? 15 I3 minus 15 I2 plus 10 I3 is equal to minus 150 minus 15 into I2 minus I3 divided by 3. Again, you will get 5 here. And what you will get here? Minus 15 I2 plus 25 I3 is equal to minus 150 minus 5 I2 minus into minus plus 5 I3. Now, let us simplify this. If I take I2 to the left hand side, it becomes positive. When it becomes positive, you will get minus 10 I2. Take this to the left hand side, it becomes 20 I3 is equal to minus 150. Let this equation number 2. Now, I got 2 equations. Now, I have to search for one more equation to solve for 3 unknowns. Now, usually whenever there is a current source common to 2 loops, then to get one more equation, we will go for super mesh technique. What is a super mesh? A super mesh is the superposition of 2 or more meshes which is formed to avoid an ideal current source. Now, these 2 meshes can be taken as super mesh by avoiding this ideal current source, because this is the current source which is common to these two loops. Now, how to avoid a current source? An ideal current source is avoided by creating open circuit, because current is 0 under open circuit condition. For the time being, assume that this is not there. If you assume that this is not there, you are going to get one loop. That loop is called super mesh. It is not a special mesh, it is a normal closed path, where in that path we should not have any current source. Okay? So, it is there as it is, but this dotted lines, it is shown to represent that it is a super mesh. So, this is the super mesh. Now, let us apply KVL to this super mesh. So, this loop is considered as super mesh. Now, applying KVL to super mesh. What is the KVL to super mesh? Applying KVL to super mesh. 30 I1. Which current is flowing here? I1. So, 30 I1. Now, 15 I2 minus I3. 15 I2 minus I3 is equal to what? Is equal to 0. Why 0? Because in this loop we do not have any voltage source. Why here 15 I2 minus I3? Because the second loop belongs to super mesh. Hence, that loop current must be taken as positive. So, I2 minus I3 is equal to 0. Simplifying this, we will get 30 I1 plus 15 I2 minus 15 I3 is equal to 0, equation number 3. Now, you got 3 equations, equation 1, equation 2, equation 3. These 3 equations now I have to express in matrix form to solve for the unknowns I1, I2 and I3. Now, let us express this in matrix form. Now, let us express these 3 equations in matrix form. So, what are the unknowns? This is current matrix, this is a resistance matrix or impedance matrix, this is voltage source matrix. You have 3 unknowns I1, I2, I3. First equation, coefficient of I1, coefficient of I2, coefficient of I3, right hand side. What is the coefficient of I1 here? 1. What is the coefficient of I2? Minus 1. I3 is not there, put 0. Right hand side 5. Next, second equation, I1 is not there, put 0. Coefficient of I2 minus 10. I3 20. Right hand side minus 150. Last equation, I1 coefficient 30, I2 coefficient 15, I3 minus 15, right hand side 0. Now, enter this matrix in the calculator to get the answers I1, I2, I3. Calculator will show the answers as X, Y, Z. Those is nothing but here I1, I2, I3. Now, all of you enter this in calculator to find the unknowns I1, I2 and I3. So, solving, we get I1 is equal to minus 2 ampere, I2 is equal to minus 7 ampere, I3 is equal to minus 11 ampere. These are the answers for I1, I2 and I3. My intention is to find short circuit current IN. So, current flowing to the short circuit is IN. The loop current flowing to the short circuit is I1, but it is opposite to this. Hence, I can write IN is equal to minus I1. That is equal to minus, what is I1? Minus 2. Therefore, what is IN? IN is equal to 2 ampere. So, short circuit current is equal to 2 ampere. Therefore, R Thevenin is equal to V Thevenin divided by IN. What is V Thevenin? 75 volts. What is IN? 2 gives what? 37.5 ohms. So, you got V Thevenin, you got R Thevenin. What is my intention? To get the Thevenin's equivalent circuit. Just write the Thevenin's equivalent circuit so that you can obtain V Thevenin and R Thevenin. So, Thevenin's equivalent circuit is nothing but a voltage source in series with a resistance. So, that is equal to 75 volts. This is R Thevenin is equal to what? So, 37.5 ohms. So, this is the solution for this problem. I hope all of you have followed.